Hello students, today we are going to start the new chapter, that is hydrocarbon. In this video we are going to study about alkane, which is the first hydrocarbon. In this part of the video we will be going to study the preparation of alkanes, whereas in the next part of the video we will going to study the chemical and physical property of the alkane. So let's start. So let's start with the first hydrocarbon, that is alkane. Alkanes are cyclic or acyclic saturated hydrocarbon. What do you mean by saturated? It means there are only sigma bonds are present in alkanes. They are also known as paraffins. What do you mean by paraffins? Paraffins means they are having little reactivity towards the particular reagent. But in the drastic condition, in the special condition when catalyst and temperature or pressure conditions are change, then they show reactivity, they show reactions like halogenation, nitration, sulfonation. All these reactions are shown by alkanes in drastic condition. But before starting the preparation of alkane, you have to recall all those things which you have studied in the earlier videos related to alkane, that is IUPAC nomenclature, structure of alkane, what type of structure is represented by alkane in three-dimensional or in two-dimensional. In three-dimensional, alkane represent tetrahedral structure in which there is tetrahedral angle of 109 degree 28 minutes, whereas in two-dimensional structure the structure is represented by Fischer projection. But there are some drawbacks in Fischer projection. Because of that, the two-dimensional structure was well explained by conformation. There are two types of conformation by which the alkanes are represented in 2D. First is Sawhorse projection and second is Newman projection. And isomerism which alkane show is nuclear or chain isomerism. These all things you have studied in earlier videos. So in this video we are not going to tell you about the IUPAC nomenclature, what type of isomerism alkane will show, or what is the structure of alkane. So in this video we are going to do the preparation of alkane. So let's start with the preparation of alkane. First preparation will be done in unsaturated hydrocarbon. First, unsaturated hydrocarbon. What do you mean by unsaturated hydrocarbons? It means there are double or triple bonds are present. So in this case there will be addition of hydrogen will takes place in the presence of catalyst. What type of catalyst? Examples like palladium, platinum, Raney nickel or normal nickel. So these catalysts are used for the hydrogenation of unsaturated hydrocarbon, that is addition of hydrogen in the unsaturated part, that is at the double bond and triple bond position to form alkanes. Okay? So in this case how the reaction will takes place? CH2 double bond CH2, hydrogen, catalyst palladium, platinum or Raney nickel. So you can use either palladium or platinum or Raney nickel. Any one of the three catalysts can be used for the reduction of alkenes. Okay? So there will be formation of alkane, that is ethane takes place. Okay? Second reaction, CH3 CH double bond CH2. This is normal nickel. This is different from the Raney nickel. Raney nickel is prepared by nickel aluminium alloy is dissolved in NaOH. Then there will be formation of fine powdered, that is a fine powdered state of nickel is obtained. That is known as Raney nickel. This is different from the normal nickel. When we use Raney nickel instead of normal nickel, then the reaction will take place in moderate temperature and pressure. Whereas when we take normal nickel, then the reaction will occur in high temperature, which is around 523 to 573 Kelvin temperature. This is high temperature. So the formation of CH3, CH2, CH3, that is propane takes place. This reaction is known as Sabatier-Sanders reaction when the normal nickel is used as a catalyst for the reduction of alkenes. ठीक है, and this reaction is occurring at the high temperature. So this reaction is named reaction. This is named as Sabatier-Sanders reaction. Next reaction for the preparation of alkane is by using alkyl halides. So the first reaction which is used for the preparation of alkanes from alkyl halide is by using Grignard reagent, whose formula is RMgX. In this, R represent alkyl group. It can be any alkyl group, and X represent halogen. So this X will be any halogen group. So what is Grignard reagent? Grignard reagent is organometallic compound which is formed by the reaction of alkyl halides with magnesium in the presence of dry ether. So let's see how the preparation will take place. If alkyl halide, example ethyl bromide, is taken in the presence of magnesium and dry ether, then there will be formation of CH3, CH2, MgBr takes place. ठीक है, this is known as Grignard reagent. ठीक है, in this R is representing this ethyl group and bromine is representing X. ठीक है, this Grignard reagent is named after the scientist who is Victor Grignard. ठीक है, who is Victor Grignard, and he also won the Nobel Prize for discovery of variety of reagents. ठीक है, this Grignard reagent is highly reactive. Why this is highly reactive? Because the bond between carbon and magnesium is highly polar because of the electronegativity difference between the carbon and magnesium. Magnesium is very electropositive metal, whereas carbon is electronegative, that is non-metal. So the electronegativity difference is very high. Because of that, this bond is highly polar. It means there is a electronegativity difference. Because of that, there will be positive charge on this magnesium and negative charge will come on this carbon. ठीक है, because of the polarity of this bond, this Grignard reagent is highly reactive in the presence of protic solvent. Example, ammonia, NH3, second, water, third, C2H5OH, fourth, RNH2, that is amine. So these are the some example of protic solvent. It means they produce H plus ion on reaction. ठीक है, in the next step, CH3, CH2, MgBr, which is Grignard reagent. Because of the differentiation of charges between this carbon and magnesium, this magnesium will attract when this is reacted to some protic solvent. It will happen, this oxygen is electronegative, that is highly electronegative atom, so this will attract this bond towards itself. Because of that, the carbon which is directly attached to this magnesium is having negative charge. It means it is electron rich, due to which this carbon will attract this hydrogen, which will be changes to H plus ion. Why it is changes to H plus ion? Because this shared pair of electron is shifted towards the this oxygen. So there will be dissociation or ionization, that is H plus and OH minus. H plus will be attracted towards this carbon which is having negative charge, and magnesium will attract OH minus because it is having negative charge. ठीक है, and magnesium is having positive charge. So there will be a formation of CH3, that is ethane, and the byproduct which will be formed by the magnesium is MgOHBr. So next reaction by which we can prepare alkanes from alkyl halide is Wurtz reaction. This is a named reaction, so this is very important reaction. This reaction is generally used for the preparation of symmetrical alkanes. So first of all, what will be the reaction? In this reaction, alkyl halide generally bromides and iodides, CH2Br, in the presence of sodium react with other molecule of alkyl halide. So in this case, the alkyl halide which are taken should be same. ठीक है, In the presence of dry ether, there will be a formation of CH3, CH2, CH2, CH3. This is butane. Okay? And the byproduct will be NaBr. Okay? So in this case, this reaction is very useful for the preparation of symmetrical alkane. Why this reaction is not suitable for the unsymmetrical alkane? Because if I explain it to you by the help of example, in this case I have taken one methyl bromide, whereas other alkyl halide is ethyl bromide in the presence of dry ether. So why this method is not useful for the preparation of unsymmetrical alkane? Because in this case, when the two alkyl halides are different, then there are possibility of more than one hydrocarbon will be obtained in the reaction. It means we will be getting mixture of hydrocarbon. So why we will be getting mixture of hydrocarbon? Because these two alkyl halides are different, so they react with themselves and also with each other. So there will be formation of 3 hydrocarbon will takes place. So what will be the hydrocarbon which will be formed? So when ethyl bromide react with itself, it will form butane, and when methyl bromide react with itself, it will form ethane, and when they react with each other, the propane formation will takes place. So there is mixture of hydrocarbon will be obtained. Because of that, the separation of this mixture is highly difficult. Why it is difficult? Because the boiling point of these hydrocarbon is almost similar. Because of the almost similar boiling point, there is less difference in their boiling point. They cannot be separated by fractional distillation. Next, what will be the mechanism behind Wurtz reaction? The mechanism behind Wurtz reaction is taken place by the two ways. First, that is formation of alkyl sodium. First, by the formation of intermediate, that is alkyl sodium. Second mechanism is taking place by the formation of intermediate, that is free radical. So let's see what will happen in the first case. So when alkyl halide, example Rx, is reacted with sodium, then because of the electronegativity difference, R will be having, that is carbon will be having partial positive charge and X will be having partial negative charge. This sodium will react with this R, that is alkyl group, because it is having positive charge and sodium is having one electron in excess, so it will donate its electron. So there will be a formation of, that is alkyl sodium. So this intermediate will be formed in which the sodium will be having positive and alkyl will be having negative charge. So this bond will be highly polar. Because of the polarity of this bond, this intermediate is highly reactive. So in the next step, this intermediate will react with the next alkyl halide. And what will be the byproduct? X minus. Next, in next step, Rx react with Rna, that is alkyl sodium. So what will happen? There is also in alkyl there will be partial positive and in X partial negative. So what will happen? This carbon ion which is having negative charge will attack on this R which is having partial positive charge, that is it is electron deficient, and this X will attack on Na plus. So what will be the next formation? There will be formation of alkane takes place and the byproduct which will be obtained. This is the next step in which the intermediate will be free radical. In this case, what will be happening? In the presence of sodium, this sodium is having excess of one electron, ठीक है, which will attract this halogen towards itself, and because of the free radical formation you can understand there is homolytic fusion, so it means this electron will be shifted towards this side and this will be shifted towards this side. So what will happen next? There will be formation of free radical and there will be formation of NaX, ठीक है. If two alkyl halides are taken, then there will be two free radical will be obtained, and because of that they will join with each other and there will be a formation of alkane takes place. So this is the mechanism behind Wurtz reaction. Next reaction of preparation of alkanes from alkyl halide is by the help of Corey-House synthesis. In this case, this method is suitable for both symmetrical and unsymmetrical alkanes. So this method is suitable for the both symmetrical and unsymmetrical alkanes. In this also the reactive reagent which will be formed is organometallic compound, and this organometallic compound is known as Gilman reagent. So first of all, let's see what will be the reaction. So first of all, alkyl halide, generally bromides and iodides, react with lithium in the presence of dry ether. Then there will be a formation of CH3, CH2, Li takes place and byproduct LiBr. ठीक है, this is ethyl lithium. In the next step, this ethyl lithium CH3, CH2, Li, in which the lithium will be having positive charge because of the electronegativity difference. This bond will be polar and carbon will be having electron rich, that is it will be having negative charge. So in the next step it will be reacting with another metal, that is copper. 2 molecule of this ethyl lithium is taken. Then there will be a formation of CH3, CH2, Cu, CH2, CH3 and lithium. ठीक है, so this complex will be formed in which lithium will be having positive charge and this complex will be having negative charge. ठीक है, this complex is known as Gilman reagent, and what will be the IUPAC now name for this complex? Lithium diethyl copper. ठीक है, this is lithium diethyl copper and this is known as Gilman reagent. So in the next step, CH3, CH2. So in the next step, this compound, that is Gilman reagent, will react with another alkyl halide, and this alkyl halide can be different or can be same. ठीक है, so in this step what will be happening? Because this is the metal due to which this will be having positive charge, whereas this carbon will be having negative charge, due to which this will be behaving as an electron rich site, behaving as a carbon ion, whereas this carbon will be behaving as a carbocation because of the electronegativity difference between carbon and bromine. So this is electron deficient, this carbon is electron rich, so this will attack on this carbon and this bromine will be removed as Br minus. So what will be the next step? CH3, CH2, CH3 formation takes place, that is propane, and this is unsymmetrical alkane. ठीक है, and the byproduct which will be formed is CH3, CH2, Cu, that is ethyl copper, and LiBr will takes place. ठीक है, so this method is suitable for both the alkanes preparation, that is symmetrical and unsymmetrical alkanes, whereas Wurtz reaction is only used for the commercial preparation of symmetrical alkanes. Next preparation method for alkanes from alkyl halide is done by the help of by using reagents. So first reagent that will be used, in this case zinc in the presence of HCl acid, that can be HCl or acetic acid can be used as a reagent. Second, either zinc copper couple can be used in the presence of C2H5OH solvent. Third, in this, either zinc in the presence of NaOH can be used as a reagent. So the general reaction, when these reagents are used, the general reaction will be given as CH3, CH2Br. In this case, there will be either bromides or iodides are used. In the presence of zinc and H+, it means they are providing H+ ion. This will form CH3, that is ethane, and Zn2+, and there will be removal of Br minus takes place. So this is a general reaction which is represented by all these three reagents. But what will be the mechanism behind this general reaction? So the mechanism given by these reagent, in the first case, when the reagent, that is zinc in the presence of HCl or acetic acid is used, and either zinc copper couple in the presence of C2H5OH is used, then the mechanism will be same. Okay? Mechanism will involve transfer of electron. Okay? So in this case, the alkyl halides are changes to alkane by the help of transfer of electrons. Okay? So what will be the mechanism? First, zinc will oxidize to give Zn2+ and release 2 electrons. These electrons will participate in the second step. In the second step, alkyl halide will react with one of the electron and there will be a formation of free radical will takes place. This X will be removed as X minus. In the third case, there will be this free radical which is formed in the second step will attack the second electron of this zinc. Then there will be a formation of carbon ion which is having negative charge will takes place. In the fourth step, this carbon ion will attack H+, which is released by this medium, that is acid HCl, or either there will be CH3, COH, then there will be formation of alkane takes place. If there is zinc copper couple is used, the similar reaction will takes place, only the difference will be in the solvent. In this solvent will provide H+ ion. So in this case, R- will react with the C2H5OH and abstract its proton, and there will be formation of RH and C2H5O- takes place. So the reaction mechanism for both the reagents are same. In this there will be transfer of electron is playing the main role. Okay? Next step, second mechanism. In second mechanism, when zinc in the presence of NaOH is used, okay, for converting alkyl halides into alkanes, then what will happen? In this case, nascent hydrogen is playing the main role. It means in this the reduction of alkyl halide is done by the help of nascent hydrogen which is provided by this reagent. So in this case, what will happen? First step, first zinc react with NaOH. So there will be formation of Na2ZnO2 which is sodium zincate, and removal of 2 hydrogen atoms, that is nascent hydrogen. Because nascent hydrogen is highly reactive, so this will proceed the reaction. In the second step, this nascent hydrogen will react with alkyl halide, and there will be a formation of RH alkane and HX. So in this case, reduction of alkyl halide is done by the help of nascent hydrogen, whereas in this case, reduction of alkyl halide is done by the transfer of electron when these two reagents are used. Second reagent which is used for the reduction of alkyl halides are reducing agent. Example, LiAlH4. Okay, this is lithium aluminium hydride. Next, Na BH4, which is sodium borohydride, PH3, SNH, this is triphenyl tin hydride. These are behaving as a reducing agent. So the general reaction which is represented by these reducing agent will be RX. Okay, so this reducing agent provide hydride ion to the reaction. There will be formation of RH takes place and removal of X minus takes place. So this will be the general reaction. In this H minus is provided by reducing agent. मान लीजिए एग्जाम्पल यहाँ पे क्या है आपका LiAlH4, that is lithium aluminium hydride. Why it is attacking on this carbon, this alkyl group? Because of the electronegativity difference. Halogen is more electronegative, so it will be having partial negative charge, whereas alkyl group is having partial positive charge. So due to which there will be formation of alkane takes place. ठीक है? So in this case, if lithium aluminium hydride is used, then this will be suitable reducing agent for 1 degree and 2 degree alkyl halides. Why not for 3 degree? It is because in the case of 3 degree, ठीक है, when 3 degree alkyl halides is used in the presence of lithium aluminium hydride, then there will be formation of alkenes takes place. ठीक है, यानी it means instead of alkane formation it will form alkene. ठीक है, next in this case sodium borohydride, it is suitable for 2 degree and 3 degree but not for 1 degree reduction alkyl halide, whereas this phenyl tin hydride is suitable for reduction of all the three, 1 degree, 2 degree and 3 degree reduction. ठीक है, so these are the reducing agent which is used for the reduction of alkyl halides. Next is catalyst. In this case, catalysts are used for the reduction of alkyl halide, which are palladium carbon or Raney nickel. Either of the two catalysts can be used for the reduction of alkyl halide. So what will happen? In this also there will be generally use of alkyl halides, or that is bromide and iodide is used. Br in the presence of hydrogen and catalyst, either you can take palladium carbon or Raney nickel. ठीक है, so there will be formation of alkane takes place, that is ethane, and removal of HBr takes place. ठीक है, so this will be the reduction method in the presence of catalyst. Now the next reagent for the reduction of alkyl halides into alkane is Hi, hydrogen iodide, in the presence of red phosphorus, temperature 423 Kelvin. It is used. In this generally alkyl iodides are used. CH3, CH2I in the presence of Hi, there will be a formation of, what will happen? Temperature will be 423 Kelvin and there will be red phosphorus present. ठीक है, so there will be formation of CH3, that is ethane, and removal of iodine takes place. In this case, what is the role of red phosphorus? This red phosphorus remove this iodine from this part of the reaction, that is from the product side. Why it is removing? Because this iodine, if not removed, then it will again react with this alkane and again form the alkyl iodide, which will be lead to this reaction will become reversible. ठीक है, because of that the production of alkane will become less. So how it is removing this iodine? Red phosphorus react with iodine and there will be formation of phosphorus triiodide takes place. So this is the role of red phosphorus. Next preparation method for alkane is from carboxylic acid. For this there are two reaction methods are given. First is decarboxylation and second is Kolbe's electrolytic method. So let's start with the decarboxylation. First, as you can understand with the term decarboxylation means there is a removal of CO2 will takes place in this reaction. Okay? So what will be the reaction? In this case, first of all, acid, that is, in this case I have taken acetic acid. Okay? So if acetic acid or some other carboxylic acid is taken in the presence of NaOH, okay, in this, first of all, you have to know what type of reagent is used. In this reagent which will be used is NaOH, okay, and quicklime. This is known as the combination of NaOH and quicklime. This is known as soda lime. Okay? The ratio of 3:1 is present, okay, in soda lime. So in this case, first of all, this acetic acid will react with NaOH and there will be formation of CH3COO Na takes place and removal of H2O will takes place. In the second step, CH3CONa, which is produced in the first step, that is sodium acetate, will react with another molecule of NaOH in the presence of quicklime CaO, okay, calcium oxide, and the temperature is 630 Kelvin, that is high temperature. So what will happen next? There will be removal of CO2 will takes place. So the product which will be obtained will be less, 1 carbon less from the reactant. So in this case, the alkane which will be obtained is 1 carbon less and it is methane, whereas NaOH will react with the next part, that is COONa, and there will be formation of Na2CO3. So there is a removal of CO2 is taking place by combining with NaOH. So this is known as decarboxylation, and because there is 1 carbon less in the product, so this is known as descent of series. It means 1 carbon less product is obtained. Okay? In this case, what is the role of quicklime? NaOH is a reagent. Okay? Whereas what is the role of quicklime? CaO. First is it is behaving as dehydrating agent. Okay? So it will absorb moisture from the reaction by which it will make NaOH remain dry. Okay? So this NaOH will remain dry because NaOH is highly hygroscopic. It is highly hygroscopic, it will absorb water and changes into liquid form. Because of that, we have to keep NaOH dry. For this, we will use calcium oxide. This calcium oxide is behaving as a dehydrating agent. So instead of NaOH, calcium oxide will absorb the water from the reaction if there is water is produced. Second role of calcium oxide, in high temperature, this will permit the complete removal of CO2. It means it will permit decarboxylation, complete decarboxylation at high temperature, that is 630 Kelvin. Okay? So this calcium oxide is responsible for the completion of reaction. Next preparation method of alkane by using carboxylic acid is done by the help of Kolbe electrolytic method. In this, electrolysis of sodium salt of carboxylic acid will be done in the presence of water. So let's see what will be the reaction. Sodium or potassium salt of carboxylate is used in the presence of water. Electricity is passed. This process is known as electrolysis. So there will be formation of ethane takes place. NaOH will be byproduct, hydrogen and CO2 will be removed. So this reaction is not balanced. So first of all, balance the reaction. 2 CH3, 2 molecule of water. So there will be formation of, okay? In this case, sodium hydroxide will be 2, then hydrogen number will be 1 and CO2 will be 2. CH3COONa, which is a strong salt, this will dissociate into CH3COO minus and Na plus, 2 ions. And because of the presence of a strong salt in water, which is a neutral molecule, so it will not dissociate completely, there will be a reversible reaction, so there will be formation of 2H plus and 2OH minus. So in electrolytic apparatus there are two parts present, one is cathode and one is anode. Okay? So these are two electrodes which are present in electrolytic apparatus. So what will happen? Cathode is having negative charge. Because of that, the ion which is having positive charge will move towards cathode, whereas anode is having positive charge, so the ion which are having negative charge will move towards anode. So what will happen? Higher will be the reduction electrode potential value. Higher will be the ability of cation to discharge at cathode. So whose electrode potential will be higher? The electrode potential of H plus is higher, hydrogen is higher in comparison to Na plus. It is very electropositive element. So because of that, its tendency to reduce itself is less. So it will remain in the solution in the form of NaOH. Whereas H plus will move towards this cathode because of the high reduction potential. So it will attract the electron of cathode and there will be formation of hydrogen takes place. This hydrogen will evolve in electrode, that is cathode. So in anode, which ion will move? There are two ions which are behaving as anion. One is CH3COO minus and other is OH minus. So on the basis of electrode potential, their discharging potential, they will discharge towards this anode. So what will happen? In this, first of all, it will lose its 2 electron. So it will donate its 2 electron to anode. So there will be removal of 2 electron takes place, one each from the CH3COO minus. So there will be formation of CH3, C double bond O, O. This oxygen will be having odd electron. Okay? So because of the odd electron, there will be homolytic fission. There are two molecules, homolytic fission. This electron will move towards this carbon. This electron will move towards this carbon. Because of that, there will be odd electron in this carbon, due to which there will be a formation of double bond takes place, due to which 2 CO2 molecule will be removed in next step. And formation of free radical, 2CH3 free radical will be formed, which will join together and there will be formation of ethane takes place. Okay? So in this case, the number of carbon which are present in the reactant sites are 4, but the product which is obtained is having 2 carbon because 2 CO2 are removed. So this is also a descent of series. Similar like the Wurtz reaction, it is also used for the formation of only symmetrical hydrocarbon. This preparation method of alkane is by using alcohols, aldehydes, ketones and carboxylic acid. In this, the reagent which is used is HI. In the presence of red phosphorus, temperature is 423 Kelvin. Okay? So what will happen? CH3, CH2OH. In the presence of HI, red phosphorus, 423 Kelvin, it will reduce to form CH3, that is ethane, and there will be removal of H2O and I2 takes place. So what will be the balancing of reaction? In this, 2HI will be taken. So there will be formation of iodine molecule will took place. Okay? And rest reaction is balanced. Next, from aldehydes, CH3, CHO, that is acetaldehyde. In the presence of 2HI and similar reagent, CH3, that is ethane, removal of H2O and I2. In this case, this will be 4. So it means there will be removal of 2 iodine molecule, H3, C double bond O, CH3, 4Hi3CH2 H2O and 2I2. This is carboxylic acid. In this case, because there are two oxygen, one oxygen is in the form of double bond O and one is single bond OH. So there will be 6Hi formation CH3, CH3 ethane and removal of 2H2O and 3 iodine because 6Hi are used. You have to balance the reaction. Every time when you write the reaction, you have to balance it. Next, fifth, hydrolysis of carbide. Example, beryllium carbide Be2C in the presence of water. How many water molecule will be taken? 4. Then there will be formation. First of all, byproduct BeOH, that is beryllium hydroxide, and formation of CH4 will takes place. Aluminium carbide Al4C3, aluminium hydroxide and CH4. Okay, in this the carbon are 3, so it means there are 3 carbons. Okay, so because of that the number of hydrogens are more. In this there will be 4 aluminium. Okay, so the number of hydrogen will be, in this case there will be 12 H2O will be taken. Okay, so you have to, every time whenever you write the reaction, you have to balance the reaction carefully, otherwise your marks will be cut. Okay, so these are the some preparation methods of alkane. In the next video we will be going to do physical and chemical properties of the alkane. So that's all for today.